Prepare a small, altered high-voltage electric imitation by wrapping transparent tape around paper to make an amniotic sac. Rub it slightly thicker, and pull it off. Use scissors to trim the edges neatly, and rub it into clay. Secure a section of wire, wrap the wire end high and fix it next to the mold. Take a part of a plastic bottle to serve as a model, aim at the center, and fix it in place. Pour 80 grams of epoxy resin into a cup lid, add about 40 grams of hardener, and a few drops of pigment, then stir to mix evenly. Pour it into the mold prepared at the beginning, filling it up completely to create a misty effect. Finally, use your fingers to peel off the outer membrane, then remove the tear film. Secure it before proceeding, and start shaping it with a direct membrane machine. Wear a mask during this step, as there is quite a bit of dust. After demolding, use sandpaper to smooth the surface, and then use a file to craft a sharp, soulful point. The insulating finger sleeve is now complete. Gradually, it feels like the deterrent effect is still not enough. Use a manual curve to saw it off, then make some minor adjustments. Mix water evenly in a high basin, slowly dip the claw tip in, and after it stabilizes and dries, grind it down. Use a sweat-absorbing machine to melt or make sweet material and just fill the mold. Polish the insulator and prepare the glue. Then reattach the modified tip. Using the same method, create a high voltage for the small papers as well. Both levels are now complete. Attach a small piece of aluminum plate with the drawn mold template, then cover it with a layer of tape. Prepare the spacer nut, apply some glue, and stick them in the reserve positions. Replace the inner and outer membranes, and use a syringe to extract epoxy resin, and inject it into the prepared mold until it is full. After drying, remove the inner and outer membranes, and use coarse sandpaper to smooth the outer surface. Before mounting, drill 2 holes to allow the high voltage electrodes to pass through the cut aluminum plate, and use a file to cleanly remove any burrs. Then cover it properly, and the electronic component storage compartment is complete. I bought a new arc lighter case, removed the internal screws, and completely disassembled it. If you disassemble too many things, they won't all fit back together properly. Remove the LED light board. This long piece is the ignition switch, which takes up space, so cut it off directly. There are also 2 transformers that are not needed. To save space, saw it in half, and break it into 2 parts, cutting off the unnecessary sections. You only need to keep one of them. Prepare a dry reed switch, which you might call a uterine switch, and then prepare a strong magnet. When the magnet approaches the reed switch, it can connect the circuit, so the original switch is no longer needed. Connect the reed switch properly for use. On the inside of the storage compartment of the live broadcast machine, grind out a horizontal groove to fix the steel pipe. The switch works normally, without any issues. Prepare a 9.19 amp CBP capacitor and a 150 amp electrolytic capacitor, and solder a simple voltage multiplier circuit with a high voltage diode. Add 2 stages of input and 2 stages of output, then try bringing the arc close to it. It's okay, your original power was a bit stronger, but it's still not enough. Open the circuit and add another capacitor lever. Wow, it works again, and the basic functionality is stronger. Let's just add another one, since there's no harm in having more. Does this effect suffice? It can even be used as a sensor. Once the circuit design is complete, compress them together to reduce the size so it can fit into the storage compartment. Connect the 2 stages of the magic algae, place it into the mold, and pour in maintenance resin for insulation. After drying, place it into the storage compartment and secure the charging port. Replace the battery and circuit board. Apply some silicone adhesive, use an aluminum plate as a heatsink, and tighten all the screws. The strap inserted into the smartwatch fits perfectly. And finally, once it's fully charged, you can enjoy playing with it. I 3D printed a ring clamp, which is positioned at the tip and stays in the middle. You can remove it from the 2 paper surfaces and place it into the storage compartment on the wrist. When you activate the high voltage, the effect is excellent. This high voltage arc looks quite intimidating, but in reality, it's not a big issue, as all the values are within the safe range.